Okay, for your last lesson on volume, we're going to put notes in our book today on volume of a sphere. These are going to get taped into your book, pages 81 and 82, so fill out your table of contents, get your note sheets ready to go. Okay, first things first. A sphere is a set of all points in space that are the same distance from a center point, that should say. Your volume formula for a sphere is a little different from the ones we've been working with. What you need to do is you need to take 4 times pi times r cubed. Notice that that exponent is not r squared like we worked with the cylinder with a cone. It's r cubed. And yes, you're going to divide all that by 3 to get an accurate volume measurement. So for the first 2 examples, we're going to do a basic sphere example. You'll notice that to show it's 3-dimensional, they try to add this little circle in the center. They're showing us here that we have from the center of the sphere to the outside, we have a radius of 11. So again, if we take our formula, we always copy the formula down first, the formula that goes with the shape you're working on. So again, it's a sphere. So we have to take 4 times pi r cubed divided by 3. And again, the only variable that we have to plug in for the sphere formula is the radius, and in our case it's 11. We do have to make sure we raise 11 to the 3rd power, so you could do that first, so you could do that after. I typically will have students put in the 4. Remember, if you're going to leave your answer in terms of pi, you're not actually going to type in pi right now. You're going to multiply by that radius. And remember to use your caret button to get it to the 3rd power. My suggestion is you work on the top of the fraction and get that value. So 4 times 11 cubed is actually 5,324. It's easier to get that example or that answer and then divide by the bottom of 3. And you'll see that we have a repeating decimal answer. 1,774.6 repeating. The calculator rounds up at the end when it runs out of room, but really we have a decimal that repeats forever. We didn't press the pi button in our calculation, so we have our answer in terms of pi. And originally we were dealing with meters, so because it's volume, our units are meters cubed. So this is what you do to find volume of a sphere. Again, being very careful with your calculations. Do the work that's on top of the fraction, get an answer, and then make sure you divide by 3. Another pretty straightforward question is dealing with a sphere, but in this case they've given you the diameter that goes all the way through the center of the sphere to both sides. So if you know the diameter is 28, remember, just cut it in half. We're going to use a radius of 14 in our calculation. And again, we're taking our formula, 4 pi r cubed. We're going to get that value, and then we're going to divide by 3. So again, we're going to skip over pi. We're just going to take 4, and we're going to times by 14, the radius, to the 3rd power. Again, we have a large value, but we're not done yet. We still have to divide that whole thing by 3. And again, we get another repeating decimal, 3,658.6. Repeating, use your repeater bar. Don't forget pi is in your answer because we're leaving our answer in terms of pi. But again, we have meters to be cubed when we talk about volume. Now there's a lot we can do with spheres when we start talking about more composite shapes. But first, we're going to practice working with a hemisphere. A hemisphere is really half of a sphere. We're taking a chop down through the middle, and we're taking that sphere and we're making 2 congruent halves. So what you'll see in this picture here is, again, just the top half of that sphere has been cut off. We're given some information that this sphere has a diameter of 15 kilometers. So what that means, remember, is if we go all the way through the center and touch both sides, your diameter is 15. So if we're interested in using our formula for volume, we need to make sure we know what the radius is. The radius is going to be half of that. We're going to use 7.5 for our radius. And what we have to do with our formula is we have to manipulate it just a bit. If we use 4 pi r cubed divided by 3, we're finding the volume of the entire sphere as if it were still whole. Because we chopped the sphere in half, we need to make sure we take half of the volume of the full-size sphere. So that's why this extra 1/2 is out here in my formula. And I'm going to leave it right there while I work on the inside of the formula. I know I've got to take 4 times pi times my radius cubed. And again, if we get that value on our calculator, we're going to skip over pi. We're just going to type in 4 times 7.5 to the 3rd power. I'm going to get that value. I'm going to hit enter, and then I'm going to divide by 3 to get the entire value on the inside. This is as if we had a sphere that was full size. I get 562.5 pi. Remember, we're dealing with half of a sphere, so we do have to cut that number in half. And that's how we get the 281.25 pi. Units are kilometers cubed. And you'll be doing this with various composite shapes that have to deal with the little hemisphere stuck to one of the other 3D shapes. Here's an example of one right here. If you've ever noticed at a farm, you might have a grain silo. The grain silo is mainly the cylinder part, but the roof on that silo will be this half of a little sphere. It's hard to see in my video, but I'm sure you can probably make it out on your note sheet. So we have a composite shape. We have the cylinder piece, and then we have this little roof that ends up being a hemisphere. So what you can see is I took my volume of a sphere formula, 4 pi r cubed divided by 3. Instead of showing the fraction in front like the last problem, I just showed that we're going to divide that number in half when we get it done. It's just a little bit easier for me to show it since this box was a lot smaller. So we have 4 times 8 to the 3rd power. We make sure we divide that by 3 to get the full volume of a full-size sphere, but again, because it's just the top part of that silo, we do have to cut that number in half. And if you do that, you get 341.3 repeating pi. The cylinder, the tall part of the silo, we can see has a height of 50. And because this half hemisphere here, this half of a sphere, fits directly on top of the cylinder, we know that they share the same radius of 8. So we're going to go ahead and use the formula for a cylinder, pi r squared h. Our radius is 8. We're going to make sure we square it and multiply by the height of 50. We get 3,200 pi. We're combining these because theoretically we could store the grain all the way up to the very tip-top part of that hemisphere. So we get a total of 3,541.3 repeating pi. And again, I believe we're dealing with feet, so it's going to be feet cubed. So again, it's just like the other composite figures that we did. You take it, you break it up into the 2 shapes, you work on the shapes individually to get your volumes, and then either combine them together to make the big shape, or, as in this example, we're supposed to find the remaining volume. What we are given here, and it's not drawn to scale according to what they're telling us, we're given a cylinder. And inside the cylinder, we have the sphere, and that sphere is taking up space. So what we're supposed to do is find the remaining space or volume that is still in the cylinder, even though we've put the sphere in there. So we're finding the remaining volume. Instead of adding the 2 shapes' volumes together this time, we're just going to subtract them to get the remaining volume. So a couple of dimensions you need to label. You've got a height of 6 meters on the cylinder. You've got a radius of 3 meters. And then they tell you that the ball, or sphere, placed inside also has a radius of 3 meters. So that's probably why they told us it's not drawn to scale, because it looks like there's room on the edge, but there really wouldn't be if we were drawing this perfectly. So I decided to work on the cylinder first. My formula for volume of a cylinder is pi r squared h. My radius again is 3, so I've plugged in my 3. I'm going to make sure we square it and we multiply by 6. Leaving it in terms of pi, again, is going to make it a little bit easier to work with our next step. I get 54 pi for the volume if this cylinder was empty. Since it isn't empty, we're going to work on the volume of our sphere, 4 pi r cubed divided by 3. So when we do this one, we have to make sure we do 4 times our radius 3 that gets cubed. And then we're going to divide that number by 3. If we get 36 pi for the volume of that sphere, we're in good shape. But remember, we are subtracting. So in order to show that you're subtracting the two volumes, it's okay to just kind of draw an arrow coming from both of these with a subtraction sign saying what you're doing next. So 54 minus 36 is going to be 18 pi. And again, this will be meters cubed because you're dealing with volume, and volume is always three-dimensional. So you'll be doing some more composite shapes. You'll be practicing some more with regular volume of spheres. Before we do that, please take a minute, get some tape. You're going to tape in your volume of sphere notes, page 81 and page 82.